Hey guys, today we're going to talk about friction. We've talked about friction and what it means in the past, but really we don't know where it comes from. So first off, frictional forces are always going to oppose our motion between two surfaces that are in contact, right? So if I'm sitting in a sled or on a sled and I'm going to propel myself down a hill, then friction is going to act up the hill because I'm going down. So friction is going to slow me down as I head down the hill, and that frictional force is going to act parallel to the surface, which is the same as my motion. Motion is parallel to the surface, so it kind of makes sense that way. So friction originates through these microscopic imperfections here along or between two surfaces, right? So this ice may look very smooth, but if you get down to a microscopic level, there are very, very tiny imperfections. So if we take a look here, this imperfection between the two systems, or between the two surfaces, is going to cause this friction reaction. And because it does, these little small particles, you can think of it like sandpaper, these little small particles interfere with one another, and they get stuck and they slow down the other object. So if we have these two perfectly smooth surfaces, so if these were perfectly smooth, then there would be no friction. But we know that doesn't exist, at least not on Earth. There are two different kinds of friction. We've got static friction. The word static means to be still, and it occurs when surfaces are at rest with each other. So these surfaces, so let's say that my two hands are the surfaces, and when they sit, when they have time, then they'll kind of settle in. And the more that these surfaces, these microscopic imperfections in my surface interact, or the more time they have to interact, the further they're going to be down, the closer they're going to get to each other. So it's going to be very hard for us to move our object. So static friction is going to be the force that we have to overcome in order to get our objects moving. So if I apply a force to my hands and I try and make it move, I've got to apply a great force to get them to separate. So this static friction is that force that prevents them from moving across. So it'll prevent motion. So in order to get started, we have to overcome static friction. So that's going to be like what our friction is to start the object to move. So I have to apply this great force to my hands because my fingers are interlocked because they've had time to sit there, and they're going to move after I apply a great enough force. So as soon as I overcome that static friction, then my fingers begin to separate and move apart, or my two objects begin to split apart. This is different than kinetic friction. The word kinetic means to move. So static friction is this friction where things are standing still, so my fingers are together because this imperfections on the surface, they stick together and I have to apply a great force to get them to move. But once I get them moving, I have this kinetic friction, this sliding friction. It's the friction to keep something moving, and generally it's going to be less than the starting friction. So once I start that object moving, it's really significantly more simple to keep it moving. So less force is needed to keep this object moving. And when we think about that, so after I've started this, my interlocking surface is moving, it doesn't have time to settle down into those gaps. So it skims across the top, basically. Those two surfaces do. So it's easier for us to keep an object moving once we've gotten it started moving. So as long as we keep applying that force, then our kinetic friction will be generally lower than our static friction. Our coefficient of friction, this is just a quantity that describes how sticky a surface is, for lack of a better word, right? So we've got this coefficient, and the coefficient of friction between two surfaces just really talks about how slick they are. The lower the coefficient, the more slick they are, the more easily they're going to move across each other. So if I have a very high coefficient of friction, then those objects are not. There's going to be a large frictional force that we have to overcome in order to get our objects to move. It's a low coefficient of friction, so approximately, let's just say 0.05, since it's a very small number, it's very close to zero, it's going to be very hard for that object, or it's very easy for that object to move. If it's a high coefficient of friction, the closer it is to 1, it's going to be very hard to move that object relative. And we talked a little bit about coefficient of friction today, or in our last class. So typically, we've got these coefficients of friction. We've got rubber on dry concrete, and this one's very relevant because police use this in accident investigations. So we've got this kinetic friction. It's to keep it moving, and it's 0.8, so we notice it's lower than our static friction. So if my brakes, as soon as my brakes lock up, then this friction is actually pretty high. So since we have a high coefficient here, that means that it requires a pretty large force to overcome this, to overcome our frictional force. So that's how police can measure the length of your skid mark and tell how fast you were going, all kinds of stuff. So steel on steel has a lower coefficient, and you can see those coefficients here. And these are just general. So that's pretty much it for what I have today. It's a short video, so take your time on the quiz, which is what's next. I'd suggest that you even, like, if you're struggling, then Google the answer. I'm going to give you plenty of time to finish it. So don't just take it and assume that you have to do it all right then and right there. So do what you can, take your time to do it, and use whatever resources you can. Your yellow book is very valuable. So anyway, go ahead and do that and complete the quiz. Thanks a lot.